So you were asked to solve for the variable and to show all work. Solve for the variable and show all work. All right, so for number 1, you were given 4x equals 32. What did you have to do? How'd you know you had to divide? All right, because 4x represents multiplication. 4x represents multiplication. So in order to solve, we do inverse operations. Raise your hand if you've heard of inverse operations. That should be everybody. If you've never heard of inverse operations, you need to make sure you write this in the left margin. Your left margin on each page is set aside for new vocabulary. So if you hear a word that you have never heard before, or you did not know what it was, you should be recording that information in your left margin. Remember, we don't write in the margin unless I tell you otherwise. So the left margin is for new vocabulary that you hear that you didn't know. Okay? So inverse operations means they are opposites of each other. So for addition, the inverse is subtraction. For multiplication, the inverse is division. I'm going to throw one at you. What is the inverse of squaring a number? I got a lucky winner. Square root. You're the second person today to come up with that answer, and we're already in 5th period. So I should have 5 people, but I only have 2. All right, so the inverse of squaring a number is to take the square root. You're going to see that again real soon in this curriculum, but it's not a problem right now. All right, so because 4x is multiplication, we have to divide. Got this huge delay again. All right, so how are we dividing? What are we dividing?
We're dividing the 32 by 30.
That's what we're doing? What do we have to do?
You have to move.
We have to divide both sides by 4. We can't just divide 32 by 4. What we do to one side, we have to do to the other. So we're not just dividing 32 by 4, we're dividing both sides by 4. So what happens on the left? What cancels out?
The 4x.
The 4's cancel out. If you just say cancel out, to me that sounds like nothing's left on the left side. So we got to be specific. So we cancel the 4's, that leaves us x, and what does x equal?
32 divided by 4.
Which is?
Which is
8. All right, so we actually use the division property of equality. The division property of equality. That's what POE represents. Property of equality. So we use the division property of equality in order to get the answer. All right? So number 2, what did we have to do?
You had to subtract.
We had to subtract 9 from both sides because 9 is
9 is being added.
How do we know we had to subtract 9? That sign doesn't tell me what I have to do. What in that problem tells me I had to subtract?
Because the 9 is positive.
Because the 9 is positive. That plus sign isn't what tells me I have to subtract. Because that plus sign is attached to A. That is not the sign of 9. So just because you see a plus sign doesn't mean I got to subtract. The sign of the number tells you if you have to add or subtract. Yes. All right, so we have to subtract 9 because 9 is positive. All right, so then what happens on the left?
The nines cancel.
The 9's cancel. We have to be specific in our words, leaving us with what on the left? A. And what does A equal? 14. What property did we use?
Subtraction.
Subtraction. Whatever operation you do, that's the property you're using.
It's still property
Yes. And the board is acting up again. So we use the subtraction property of equality for number 2. So I'm writing this information on the board for a reason. You're going to see it again real soon. All right, so number 3. On number 3, you were given a fraction, and a fraction represents what operation?
division.
Division. So because it is division, what's going to be our first step?
Multiplication.
All right, and what are we going to multiply?
Multiply with 3 on both sides.
3 on both sides, because that's what we want to get rid of. All right, what happens on the left?
The 3's cancel out.
The 3's cancel out. And it leaves us.
N is equal to
And what does n equal?
48.
48. And the property?
Multiplication.
Multiplication property of equality. Multiplication property of equality. So which one didn't we use? The addition property of equality. All right. So below that, you are going to write opening and box it in, because we're moving on. All right, so in the opening, the first thing we're going to do is we're going to copy down the standards and the learning target. So it is also on the whiteboard to my left. Please disregard how it looks. Board was acting up in first period and it's starting to act up again. So your learning target, your standards for today are MGSE 9 through 12.N.Q.2, MGSE 9 through 12.A.CED.4, and MGSE 9 through 12.A.REI.1. All right, so we are dealing with 3 standards today. You will receive a small packet that has all of the standards so that we don't have to worry about you writing them, because you have to keep track of which ones you've mastered and which ones you haven't.
So
You just write the numbers. You're writing the numbers. MGSE 9 through 12.N.Q.2, A.CED.4, and A.REI.1. So these are the standards that we're going to be looking at. When you are done copying the standards and the learning target, please place your syllabus acknowledgement sheet on top of your desk so we can come around and pick them up. Remember, if you don't return it, you don't get a textbook, and you don't get to borrow someone else's either. In case you are worried about pages, you get a total of 3 pages each day. Well, why you sit back then and if you can't see it? You gotta sit close to the front. The learning target for today is I can solve linear equations in one variable using guess and check, working backwards, and using properties of equality. All right, so I am going to show you an example of all three methods. Now, you do not have to use all three when you are doing work, but I must show you all three. You will be required to do all three in your practice. After today, you can decide which method works best for you, and that's the one that you can use. Okay? examples that we're going to do are going to all be the same question. So by the time we finish the first one, we're going to know the answer. So that should make going through the other two examples a little faster. Here's our first example. We are going to solve 5y minus 9 equals 16 using guess and check. Using guess and check. So, somebody give me a guess on what y equals. That should be quick. Yes. All right, so did you work it out or did you give me a guess? Right, that's not what I asked. I didn't ask you to do mental math, I asked you to give me a guess. So you immediately went to let me solve it. Guess and check doesn't work that way. So we're going to do 3. So I'm guessing 3. I'm guessing that 3 is the answer. And I'm going to check to see if it indeed is the answer. So to do that, I substitute that guess in for the variable. So then what do I have to do? I have to multiply 5 times 3. And what is 5 times 3? 15. So then what is 15 minus 9? What's 15 minus 9? It is 6. So then does 6 equal 16? No. So it is not an answer. So my guess gave me an answer that is smaller than the solution I needed. So that means my guess has to do what? It has to go up. So for sake of time, those who did mental math that you're not always going to be able to do for guess and check because it won't always work out evenly. 5 is now my guess, so I'm going to plug in 5. And I do the same math again. So what will I have on the left? 25 minus 9. And what is 25 minus 9? 16. So now that both sides are equivalent, I can write a solution statement of y equals 5. So to sum up, guess and check, if I make a guess and my answer is bigger than what I needed, what must you do with your guess? Make it smaller. If my guess produces an answer that is smaller than what I need, then what happens with my guess? I've got to go up. Questions? All right. So then let's look at working backwards. Yep. So now this time we are going to use the method of working backwards. Students have seemed to find this one a little difficult, but it's okay because remember, I have to show you all 3, but you don't have to use all 3, at least after today, that is. You have to use all 3 today. But after today, you do not have to use all 3. All right, so we are working with 5y minus 9 equals 16. And what did we do to the term that has the variable? What did we do to the term that has the variable? We're not switching anything. What do we do to the term that has the variable? So this is the term that has the variable. What do we do to the term that has the variable?
Divide it.
Y'all not listening to my question. You're telling me how to solve it. What did we do to that term 5y?
Not separated.
It's not separated, it's together. What you mean it's
So you put a
separated?
box around it,
So that's together, right? So we didn't separate it. What did we do in this problem to that term that has the variable? Look at the problem. What did we do to it? Nope. So that term is one piece by itself. What do we do to the term? I didn't switch anything. All I did was put a box around the term. What do we do to that term? It's in the problem. The answer is in the problem. What did we do to the term that has y? We took 9 away. Isn't that what it says? We took 9 away. We subtracted 9 to that term, did we not? That's what comes behind it, right? So we took 9 away. So if I'm going to work backwards, if you take something, what do you do if you go backwards? If you reverse it? I ain't said nothing about subtracting and adding. I said I took away. So what's reversing? Taking it away. You put it back. You got to listen to the questions. If we took 9 away, we have to put 9 back to work backwards, to reverse it, right? You take 5 pieces of candy. If you're going to reverse it, you got to put 5 candies back. So if we took 9 away, what do we now, and we put it back, what do we now have? If we took 9 away and we put it back, what do we have on the right?
25.
We have 25. I took 9 originally, but I got to put them back. So if I put 9 back, how many do I have? I have 25. 9 plus 16. I took 9 and I had to put 9 back. So if I put 9 back, how many do I have? I have 25. All right? So if we know our multiplication facts, then we now know what y equals. What is y? Y is 5 because 5 times 5 gives me 25. If your answer is going to be a fraction, it'll be a little bit more complicated. So that's working backwards. So if you take something, you have to put it back. If you divided it up, you got to put it back together. Questions on working backwards? They'll come shortly, I'm sure. Hopefully not, but I'm expecting it. You don't have a calculator. All right. Last example. Same problem. But this time we're going to use properties of equality. Same problem, but we're going to use properties of equality. All right, so what's the first property I'm going to use?
You gotta add 9 on both sides.
So what's the property?
Addition.
Addition, property of equality. Everybody say addition, property of equality.
Addition, property of equality.
So in order to move to the next step, I must use the addition property of equality. And what told me that?
The negative sign.
The minus sign. All right, so the addition property of equality says I have to add the same constant to both sides. The property of inequality for addition says that I am adding the same constant to both sides. So what do we have to do now?
The 9's cancel out. And you gotta add the 16 and 9.
And that means we are simplifying. So I'm going to simplify in my work. So notice I am giving the work and I'm giving the justification statement. You're going to be required to do that. So you told me that the 9's cancel, which leaves me with what on the left?
5y.
5y. And what will be on the right? 25. What's my next justification? Division, property of equality. So what do we have to do? Divide 5 on both sides. So what's my next justification step?
Y is equal to, or y.
Justification.
Oh, you gotta cross out the 5.
Justification. So what's our justification? What do we have to do? I heard it. Simplify it. When you do the math, you are simplifying it. So I've got to simplify it. And when I simplify it, I get what as a solution?
Y is equal to 5.
Y equals 5. So your learning target is to be able to use all 3 methods. That is guess and check, working backward, and using properties of equality. All right, any questions on the 3 methods? Now's the time to ask. All right, we're getting ready to go into the work session. And if you have a question or you're running into some problems, remember you have your communication cards so that we can assist you. Green means I'm good. Yellow means I'm a little iffy about it. Red means I'm completely lost. We shouldn't have any reds because then nobody asks any questions. If you're on red, you should have been asking questions. Got to learn how to ask questions during the instructional period. Okay? So for number 1, you're going to keep working as you go. Don't forget to write the work session. For number 1, you must solve it by guess and check. No options. For number 2, you must solve by working backwards. For 3 through 6, you must use properties of equality and you must give me the justification statements, just like we did in example 3. don't forget, for each problem, you should be writing an equality statement. So for number one, somewhere you should have written x equals something. Otherwise, you haven't given me the solution. You just gave me a justification through work. So make sure that when you finish, that you give me an equality statement. What does the variable equal?
Why don't you do number 3 the same way you did 1?
Huh?
Why don't you do number 3 the same way you did number 1?
No, 3 through 6 you do like we did example 3 with your properties written out for each step. You're either given a property of equality or you are writing or you're simplifying. So you do 3 through 6 like we did example 3. They're not always gonna be written this way. Some you're gonna see this way. Correct. So again, remember, for 3 through 6, you must provide your justification statements for each step. So you're not just working out 3 through 6. You have to give the justification statements beside each step.
If they have the same denominator, yes. If they don't have the same denominator, you gotta make it have the same denominator first.
So how would I do that whenever I'm describing it with the?
You know, that's just a part of your simplifying, right? Because you gotta come up with a solution. So you don't have to tell me how you simplified it as long as you.
So I just like, so I can do subtraction, or subtraction would be made,
Uh-huh.
and then simplify it.
Mm-hmm.
So for you gotta have more than just the properties. The properties ain't gonna get you to the solution. You gotta have some properties and some other stuff to get you to the solution.
So same process, even though you have the negative in front. Okay, so if you subtracted 3 on this side, what did you subtract on this side? We added 9 there because we were doing the inverse of minus number. So that's the paying attention, notice for the class. You know we got no notice. So your justification for this step is going to be what are you doing to both sides? So then your justification is going to be subtraction what? Subtraction probably will be equal. What you do to one side, you have to do to the other. So you can't subtract 3 here and subtract 9 there. You have to subtract the same thing. And then put your justification on the outside.
So, Ms.hill said.
Oh, why you just say that?
And then so for the last, for those parts where you gotta divide when you
You do? A fraction is what? Operation. Division. So then to get rid of them, we gotta do what? Divide. What are we trying to get rid of? So what are we trying to get rid of? What number are we trying to get rid of? The 3. So the inverse of division is multiplication, so we're gonna multiply both sides by 3. We're not gonna divide, because it's a fraction, right? So once you get started on the problem, we can help walk you through it, right? So you should have a justification for each step.
I had it right, but it's one of those things. We do the cross, but before you do that, I just see, I just went and read subtraction, so if I
So just a little FYI, if on number 6, your second POE, probability of equality, if it is division, that is wrong. If your second property of equality for number 6 is division, that is wrong. Just want to give you that FYI. Yes. So a fraction is what operation? Division. So if a fraction is division, then your property of equality can't be division, right? Because your property of equality has to be the what? What words did I give you? What's the same as opposite? I gave you a word that we talked about today. Inverse. You gotta remember that word. We're doing inverse operations. Again, that's a nice word to put in your left margin. Inverse operation. It's not going away.
Nobody's that close to you, but okay.
your first step? No, you don't need to come to the update. What's the first step? What's the first step? So be your first step. What do you want to get rid of?
Not really. Alright. Not right. Okay. Thank you. You're welcome.
We don't want to get rid of why at all. We need why.
Well, I like that.
Solve it for if we don't do it. So the first step would be to remove what? You need why. Why don't you get rid of this? What's with it?
I can't get down with it.
Okay, so we got your 1/3 why. Can't do anything to that. We gotta get rid of the one. So what do you want to do?
Why you trying to
So we're gonna subtract 1/4 from both sides. So when you get ready to subtract, so you don't have to do it at the start.
You know I was they pay all day so it's about money. Guess what?
Not yet. Just based on what you have, you don't have to get confident on that yet. You will have to, but not right now.
Except we in big circles.
All right, raise your hand if you have completed all 6. Raise your hand if you have completed all 6. All right, so those of you who have not completed all 6, you have a little work to do. So you need to make sure that you leave enough space to finish all 6 problems. So we are going to do our closing. We are going to do our closing. We must close each class. All right? So, our closing, for the closing, you're going to be doing it in your composition book. For the closing, you are going to answer the following question in complete sentences. You're going to answer the question in complete sentences. Okay? Are we ready? So, the closing today is, what is, you do not have to write the question, you just got to answer it. Which method of solving do you think is more efficient? Explain your answer. That doesn't require any talking. You are answering, which method of solving do you think is more efficient? Explain your answer. So we had 3 options: guess and check, working backward, and properties of equality. So you are answering, which method of solving do you think is more efficient? Explain your answer. So your answer should be in complete sentences. Do not give me a run-on sentence.
get 2 boxes.
Wait, say that again.
Huh?
What'd you say?
Get 2 boxes.
So you're putting 2 in?
Dude, 145 is taken.
Oh, okay, yeah, go ahead. You're right.
Volunteer to share your answer. Volunteer to share your answer. I'm a voluntold, so we can volunteer, or you can be voluntold. Your answer is your answer. There's no right or there's no wrong answer here. Volunteer to share. Okay? Yep.
I put guess and check because it's easier to once you get the thing and then you solve it and if it's not right then you know whether to go higher or lower and then yeah it'll take you more time or whatever but you'll end up getting the right answer.
Somebody else? Somebody else want to share? What did you say was more efficient? Which way?
So that the last one, POE, is more efficient.
What's POE?
Properties of equality, because it doesn't require as much thinking, and if you don't have to do it step by step and do it mentally, it'd be a lot faster.
Okay. Did anybody choose working backwards? Oh, really? I wasn't expecting that. Oh, no, you're going to have to take it out. Class ain't over. I don't know why you taking up.
I know that's it. I want to see.
Okay.
I said out loud, I only one.
Did you see the
I said, I thought it's easier and it's easier than not right.
All right. Remember, if you did not finish all 6, you have to finish all 6. Make sure you push your chair up, Ms. Johnson. Make sure you push your chair up.
Yeah.